Module 5, problem number 5. In 1940, an organization surveyed 1,100 adults and asked, are you a total abstainer from or do you on occasion consume alcoholic beverages? Of the 1,100 adults surveyed, 363 indicated that they were total abstainers. In a recent survey, the same question was asked of 1,100 adults and 297 indicated that they were total abstainers. Complete parts A and B below. Determine the sample proportion for each sample. Okay, so we're looking at two samples. The first is the survey from 1940. The second is the more recent survey. So as you can see here, remember from about module 2 that the proportion is the number of successes divided by the total number in that sample. So for both of the samples, the N or N1 and N2 are both equal to 1,100 because they're both 1,100 adults were surveyed. In the first survey, X1, the number of successes was 363, and in the second was 297. So to find those proportions, we do P1 equals X1 divided by N1, which is 363 divided by 1,100. That gives us 0.33. We do the same thing for P2. It's going to be 297 divided by 1,100. That's going to give us 0.27. So let's put those in, 0.33 and 0.27. 0.27. Fantastic. Part B, has the proportion of adults who totally abstain from alcohol changed? Use the alpha equals 0.05 level of significance. First, verify the model requirements. All right, so pull up our requirements. All right, so here we have 3 requirements. The samples are independently obtained using a simple random sampling or through a randomized experiment. Well, it doesn't say that, but the fact that it's done by an organization that surveyed it, you can assume that it's done randomly and that they are independent samples. So let's go to our list of checks here. The samples are independent, so we're good there. The second requirement, N1 times P hat 1 times 1 minus P hat 1 is greater than or equal to 10, and the same thing for the second sample, N2 times P hat 2 times 1 minus P hat 2 is greater than or equal to 10. So by going back to our numbers, we plug that in, we end up with 1,100 times 0.33 times 0.67, which just gives us 243.21, which is clearly greater than or equal to 10. That's for the first sample. The second sample, we have 1,100 times 0.27 times 0.73 equals 216.81, which is greater than or equal to 10. Again, those numbers just came from our samples. So that P1 and P2 we found, and then 1 minus P2, it's just subtracting. So when we subtract, we get that 0.73. So both of those we can verify. So let's go back. That would be the second one there. And then let's look at our requirement again. So this one, the last one, talks about N1 being less than or equal to 5% of that population. Just making sure that it's small enough, basically. Now, again, it's not mentioned specifically in here, but we can infer this. The fact that it's only 1,100 adults, and they're talking about a broader population, you could assume maybe even the whole US or whichever geographic region they're in, 1,100 is clearly going to be less than less than or equal to 5% of that total population. So we can say the sample size is less than 5% of the population size for each sample. All right, so those are the 3 requirements. Check answer. Excellent. Let's move on. Okay, so identify the null and alternative hypotheses for this test. Let P1 represent the population proportion of 1940 adults who are total abstainers, and P2 represent the population proportion of recent adults who are total abstainers. So determine the null and alternative hypotheses. First, so one of the things I mentioned in the lesson that's mentioned in the book and the webinars is that your null hypothesis is always that P1 is equal to P2. That's always the case. So we can knock that off real quick. So let's go back to our problem to figure out what we're trying to prove, like what's our hypothesis that we're trying to show. So it says here, let's go back. Here, has the proportion of adults who totally abstain from alcohol changed? Now, if they had said increased, then we would see if P2 is greater than P1. If they said have the number of total abstainers decreased, then we would say that P1 is greater than P2. The fact that they say just changed tells us that they just want to know if these two proportions are different from one another or not equal to. So let's check our answer. Well done. Find the test statistic for the hypothesis. So I already opened up a little window in StatCrunch. We're going to go to Stat, Proportion Stats, because again, this is a proportion. We're going to go to sample and with summary, since we don't have the data set. So our number of successes for the first population, which was the 1940 survey, is 363. The number of observations in that sample was 1,100. The number of successes for the more recent survey was 297. Again, this is just being pulled from right here, our X1 and X2. And then the number of people surveyed was 1,100. Let's go back down here. So we remember that P1 equal to P2 is the same thing as saying P1 minus P2 is equal to 0, just by subtracting P2 from both sides. So this right here is already set up the way we need it. And again, our alternative is that they are not equal to one another. Those are the three options. Okay, click compute. That gives us our test statistic. You see here the Z-stat, that is our test statistic in this case, Z naught. So it's, we need to round to 2 decimal places. That gives us 3.07. 3.07, check answer. Well done. Determine the p-value. What's great is that we already have it when we ran that test. It says to round to 3 decimal places. So here we have our p-value. 3 decimal places give us 0.002. Good job. All right, now, this is how we're going to interpret this. If the population proportions are equal, that's assuming that the null hypothesis is true, one would expect a sample difference proportion greater than the absolute value of the one observed in about blank out of the 100 repetitions of this experiment. The way you do this is you multiply your p-value by 100 because it says here 100 repetitions. That when you multiply this by 100, you get 0.2. When you get 0.2 and it says round to the nearest integer, we would say 0 in this answer. Check answer. Fantastic. All right, state the conclusion for this hypothesis test. So our alpha, let's scroll back up to double check, is 0.05. Our p-value is 0.002. Our p-value is less than alpha, therefore we reject the null hypothesis. So right off the bat, we know we're looking at options B or D. When we reject the null hypothesis, we're saying that there is sufficient evidence to support the alternative. Think of it this way. If we rejected the null hypothesis cannot be true. We cannot also say that there's not enough evidence to support the alternative because then nothing's true. And that's just not a possible outcome. So if we reject the null, then we have to say that something supports the alternative. And that right there is option B. Check answer. Awesome. So that's how you do number 5 from module number 5. Let me know if you have any questions.